Okay, now the numerical says a wooden block floats in alcohol. So first of all, flotation is in alcohol. And it says that the block is floating with 3 by 8 of its length above the alcohol. So what we will do, first of all, we will consider length of block. So let the length of block, which is not given to us, be capital L. Now they have given us what length is above the alcohol. So length above alcohol. It is 3 by 8 of the total length. So we can get length below, that is length immersed. So the total length is L. From it we will be subtracting 3 by 8 L. So that will give us 5L upon 8. So this much of length is submerged. Now if you go through the question, then they say the block is of uniform cross section. Okay, now we know that whenever a body floats, so for a floating body, I told you we can always use this formula: volume of the body submerged upon the total volume is equal to density of the solid upon density of liquid. So this relation we can use whenever a body is floating. So here the body is floating, so we can use this relation. Now further, as the body is of uniform cross section, so what we can do in this formula, volume submerged can be replaced by area of cross section into small l, that is the length submerged. Volume submerged will be written as area of cross section into length submerged. This is capital V, that is the total volume. So it will be written as area of cross section into total length, capital L. So area of cross section will cancel out as the body is of uniform cross section. So we are getting the relation length submerged upon total length is equal to ds upon dl. So remember, first of all, we have this formula for a floating body, and if it's given in the question that body is of uniform cross section, then you can rearrange this formula like this. Small l is the length submerged, capital L is the length of the body, density of the solid upon the density of liquid. So let us substitute here. We have small l, that is the length submerged. So the length submerged is 5L upon 8. So it is 5 by 8 of L divided by total length. So the total length is considered as capital L, is equal to density of solid. So density of solid is not known to us, upon density of liquid. Here the liquid is alcohol, and you can say they have given you the density of alcohol. So it's 0.80. This L will cancel out. So you will be getting 5 by 8 is equal to ds upon 0.80. So when you cross multiply it, you are getting density of solid 5 into 0.80 upon 8. So that will give you 0.5. So we have got density of solid. So we have got density of solid as gram per cubic centimeter. So after getting the density of solid, now the same solid, as you can see the question says, the same solid, it is made to float in water. Now we are making the body, same body, to float in water. So now flotation is in water. Flotation in water. Now the length of the body remains the same. So the length of block was considered as capital L, it will remain the same. But now the length which is above, they are asking what fraction of its length is above the water. So what we will do, we have considered the length of block as L. Now we will consider length submerged. It's not given to us, so let the length submerged be small l. Density of solid is known to us, we have already calculated it, 0.5, and density of water is also known to us as 1 gram per cubic centimeter. Here the body is floating in water, so the liquid is water, so you will take density of water. Now again, as the body is floating, so we know for a floating body, volume submerged upon total volume is equal to density of solid upon density of liquid. Now if the body is of uniform cross section, we can replace small v by A into length submerged, capital V by A into total length. A will cancel out, we are left with small l, that is the length submerged upon capital L. On this side, density of solid, it's 0.5 upon density of liquid, it's 1. So on solving it, you are getting 5 upon 10, that is 1 by 2. Now this small l upon capital L, what does it represent? See, small l, it is unknown to us, that is the length submerged, unknown to us. Length of the block, that is also unknown to us. So together we can call it as fraction of length submerged. So what we have calculated here is fraction of length submerged in water, that is 1 by 2. Now what we have to get, we have to get fraction of length above the water. Now remember, total fraction is always considered as 1. So from 1 you will subtract the fraction which is submerged. So the fraction which is submerged is half. So when you subtract half from 1, you will get 1 upon 2, that is the fraction of length above the water. So the fraction of length above the water will be 1 by 2. Hope this is clear to you now.